Welcome to Software Coding for Beginners. I am Olaoke, your trainer. I have over 25 years experience of analysis, design, and coding in various programming languages and databases. Coding or writing software is the act of instructing a computer to carry out one or more tasks, e.g., do addition or do subtraction. The topic we are covering today is variables. However, before we go into the details of variables, let me introduce you to a short code. This will enable you start off with a picture of what coding is. To skip this section, please see the timeline of the video in the description below. On the screen, you have code that receives two numbers from the user. After adding the two numbers, it gives the user the result of the addition. So, when this code is run, it will create an app on the mobile phone that you can see on the screen. So this mobile phone is known as an AVD, which stands for Android Virtual Device. An Android Virtual Device is a phone on your computer. So it behaves exactly like the physical phone. When developing Android applications, you have a choice of testing your application on a virtual device like the one on the screen, or you can actually connect your Android phone to your computer and test your code on your actual phone. The tool in which you can see the code and the Android phone is known as Android Studio. It is a free tool for developing Android applications. Okay, let's run the app. So the application is getting created. So for now, I'm going to enter 22 and 47. But I'm not going to click the button yet. So I'm just going to run you through what's going to happen when the button gets clicked. After clicking the calculate button, the code on the screen gets executed from top to bottom. So the first three lines of the code creates what are known as storages. They are storages for storing integer values. So the storages are input 1, input 2, and result. Once they're created, the next line gets the first value entered by the user, in this case 22. After getting it, the value is stored in input 1. Remember, input 1 is a storage that we created above. The second value is brought in by this next line, line 46. And that value is stored in input 2. And on the next line, which is line 47, the calculation that the user has asked for is carried out. So remember, 22 is stored in input 1 and 47 is stored in input 2. So it is the value stored in the storages or variables. It is the values that are stored in them that the code is going to see when it references the name of the variables. So in this case, what the code sees on this line, line 47, is 22 plus 47. Because of the plus operator, which is the plus sign, the two values will be added together, and then the result will be stored in the storage that we named result. And the reason the result will be stored in a storage named result is because there's an equal sign, or more technically known in coding as an equal operator. And what that operator is telling the code is it wants the value on the right-hand side of the equal sign to be stored in the storage named result. So once we finish on this line 47, the calculation has been done. The result is stored in the result storage. And then the subsequent line 48, we start to prepare to report back to the user. And on line 49, we actually write the report. So before I explain line 49, I'm going to now click the calculate button so you see the report on the screen. If you look on the phone screen, you will see that the report written in green is consistent with the report that we created in the code. The report on the screen starts with 22, and that's the first thing that is mentioned in the report written in the code. Remember, input 1 has values 22 stored in it. That's what we'll be seeing there. Then its next word is plus. Plus is showing in the report on the screen of the phone. Then the next thing we have is input 2, the value stored in input 2, which is 47. And the same is on the screen. Then we have the word is, and we have the word is there, and we have colon. And then finally, we have the value stored in the storage named result, which stores the sum of input 1 plus input 2, which is why we are seeing 69. Yeah, that brings the demo to an end in Android Studio. Please note, the Android application that you saw in the demo is available for download in the description section below this video. Please understand that you do not need to be good at mathematics in order to learn coding. With or without a calculator, if you can work out the correct answer to 7 times 4 or 15 plus 79, then you are competent enough to learn coding. Java programming language will be used for this course. However, please note, the focus of this course is on teaching coding, not Java. Nevertheless, since Java language is used for teaching the course, you will indirectly learn some Java. Please also understand that you can learn coding in any programming language. After you have learned how to code, you can then specialize in Java or Python or any other programming language you prefer. Since the course is going to be taught using Java, you will need to install Java and a tool known as Eclipse. To install Java, go to Google and search for Java download. In the results screen, go to Oracle's site for the download. Once you get to the site, download the latest JDK. In this case, JDK 24. Then scroll down in order to specify the operating system that you want to install Java on. In my case, so I'm going to click Windows. Scroll down to download the x64 installer, or whichever installer you prefer. After the download, go to the top right-hand corner of your browser or wherever the download is showing on your screen and click Open File. If your download screen is not showing, then go to the Settings menu of your browser and click on Downloads. Click Open File. This screen will pop up. If you are happy to proceed with the installation, click Yes. So this screen will come up next. Just click Next. In this screen, you can change the folder that Java is going to be installed to. If you don't want to change it, then click Next. At the end of the installation, this screen will come up. Close it, and that's it for installation of Java. So the next thing that needs to be installed is Eclipse. To install Eclipse, go to Google, search for Download Eclipse. Choose the result for eclipse.org. Download this option that has the Eclipse logo. When this menu comes up, choose Download x86_64. You will be presented with a server from which to download. So click the Download button. The download will come into view. Click Open File. The installation will commence. This screen that gives you a list of Eclipse installation options will come up. Either choose the option for Eclipse IDE for Java developers or Eclipse IDE for enterprise Java and web developers. As you can see, the second option includes tools for Java web development. Once you're happy with the folder settings, then click Install. Please remember that what you see on your screen may vary depending on the browser you are using. Please remember to take note of the directory that Eclipse is installed into. You're going to need to reference that folder later on when you want to start up Eclipse. After the installation, the Launch button will come up. Click it to launch Eclipse. In the course of the launch, this screen will come up. If you are happy with the folder that Eclipse has specified, then click this option. Use this as the default and do not ask again. If you're not happy, change the folder by clicking the Browse button and then specify your preferred folder. In my case, I'm going to accept the default folder. Please note, in future, if you want to launch Eclipse, you need to go to the folder that you installed Eclipse into. If you accepted the folder suggested by Eclipse, then the folder that your Eclipse is installed into will be similar to mine. To get to mine, I go to the C drive, then I'll go to the users folder, then I choose my username, and then the Eclipse folder, and then the installation that I've just done, and then the Eclipse folder inside that. And now I have the Eclipse files. The file that you need to run is this one, the Eclipse executable file. Double-click it, and Eclipse will start launching. When the launch completes, this screen will come up. To proceed to use Eclipse, go to the top right-hand corner and click the Hide button. You are now in a position to do Java development in Eclipse. You will now need to create a project. To create a project, go to the File menu at the top left-hand corner, expand the File menu, then click New, then go to Project, then this screen will open up. Go to Java, expand Java, then click Project, then click Next button. Give the project the name Coding. Then click the Next button. That should take you to this screen. Then click the Finish button. So this screen, Open Associated Perspective, will pop up. It's merely asking you if you want the most suitable screen configuration for Java development. Since we'll be using Java programming language, accept the offer. So in order to do so, click Remember my decision, and after that, click Open Perspective. The coding project is now created. In order to start coding, you need to create a number of things. So the first thing you need to create is what is known as a package. A package is the same as a folder on the operating system. It will be for storing the files of the code that you create. More technically speaking, it is for storing the classes that you are going to create, because any code you write is going to be written inside what is known as a class. So right-click the project named Coding, and then click New, and then select Package. This screen should come up, and then in the name field, give it the name Coding in lowercase. This will be the name of the package. Click the Finish button, and you have your package created. So the next thing that you need to do is to create a class. Because as I said earlier, any code you write is going to be inside a class. So right-click on the package you've just created, click New, and then click Class. In the name field, specify the name of the class. In this case, calculator. The first letter must be in capital, because the naming convention in Java is for class names to start with capital letter. Next, click the Finish button. After creating the class, it will automatically be opened in Eclipse. You will come back to the class when you get to the exercises that are part of this tutorial. For whatever reason, if a class is not open in Eclipse and you want it open, then you need to go to the location of the file in order to open it. So let's start off by closing this file, calculator.java, by clicking the X in the tab of the file name. So to open this file again, you go to the project that the file is in this case, Coding, expand the project, then expand the source folder under the project, then expand the package or folder that the file is stored in. Remember, when you created the class calculator, you created it in the package named Coding. Now you can see the file. Double click it and you will have the file reopened. Please note, any code that is relevant to this training will be written between these two lines. So both lines are for adding notes to code or software that you write. So they explain what is happening in the software so that when you come back in a week's time or in 2 years' time, you will easily understand what the code is doing. So the first line is known as a single line comment. Any note that you write must be on one line. The second line is known as a multi-line comment. Any note or comment that you write can be on multiple lines. So you can have it this way if you want. So we now have code between the two lines. In line with what I've just explained, the code starts from line 19 to line 26. In this case, we have code that collects two numbers from the user and then adds them together and then gives the user the result of the addition. As I mentioned earlier, the topic we are covering today is variables. Variables are one of the key building blocks of any software code. A variable is a named storage into which a value can be stored and retrieved. The value stored in a variable can be changed. Please note, a variable cannot store more than one value at a time. In Java, the name of a variable is written in lowercase. However, if the name of the variable is made up of two or more words, the first letter of the second, third, and subsequent words must be written in capital. This is known as camel case. A variable cannot have any space between its name. An example of a variable is input 1 on the screen. This is for storing integer values. As you can see, the variable is made up of two words, input and 1. So remember, the variable name is supposed to be in lowercase, but if it is made up of more than one word, then the first letter of each subsequent word must start with capital. Data types. Data type indicates the type of value that can be stored in a variable. In Java, a variable must have a data type. There are multiple data types. This training will only focus on string, int, and float data types. As I mentioned earlier, string data type is for storing character data. Int data type is for storing integer numbers. And float data type is for storing floating point numbers. Remember, an integer is a number that has no decimal point or dot. What you have on the screen is code that creates 6 variables. Remember, variables are for storing values. So the first two lines, line 20 and 21, create what are known as string variables. In order to do so, you specify the data type, then you specify the name you want to give the variable, and if you decide to give it a value at the time that you are creating it, then you specify the equal sign, which means whatever is on the right hand side of the equal sign should be stored in the variable on the left hand side of the equal sign. So after the equal sign, you specify the value that you want to store in the variable. The following two lines create variables for storing integer values. Again, you specify the data type first, then you specify the name of the variable. And since you are not giving the variable a value at the time of creation, you don't need to specify anything else. Just the semicolon for saying that's the end of that line. So that's it for integer variables. Next two lines, 24, 25, create float variables. So again, the first thing you do, you specify the data type float, then the name that you want to give the variable, in this case, it's weight. And because you want to give the variable a value at the time of creation, you specify the value. As you can see, the value stored in the float variables are floating point numbers. That is, numbers that have decimal points. It is now time for you to do some exercises. Before proceeding, go to the description below and download the file named coding_variables.txt. Open the file, then copy the code named code template for exercises. This is the code in the file, and the lines you want to copy are from the word package all the way to the closing curly bracket. Next, go to Eclipse and open the class file you created earlier, named calculator.java. To open it, go to the coding project, expand it, then expand source, then expand the coding package, and then you'll see the file calculator.java. Double click it, and you have it open. Next, delete everything in calculator.java. Then paste what you copied. The calculator.java file should now look like this. Remember, the code that you write for your exercises must go between these two lines. Go to exercise 1 in the file and do the two exercises. That is, create a variable named total seats for storing integer value. And secondly, create a variable named last name for storing character value. Pause the video while you do the exercises. I'm about to show you the answer for exercise 1. If you have completed the exercise, then continue playing the video. So this is the solution to the exercises. Remember, the first exercise requires you to create a variable named total seats for storing integer values. For a variable to store integer values, it must have a data type of int, which is specified here. And then after the data type, you specify the name of the variable. So that meets the requirement of exercise 1. For exercise 2, you're required to create a variable named last name for storing character values. A variable for storing character values must have a data type of string. And after specifying the data type, you then specify the name of the variable. So that completes the exercise. If you are benefiting from this video, please like it and subscribe. Amongst other things, this will enhance the likelihood of you receiving notifications when we release new videos. Variable assignment. You will recall that variables are for storing values. The act of storing a value in a variable is technically known as assigning a value to a variable. In order to assign a value to a variable, you need to place the equal sign or operator after the variable name. After the equal sign, type the value you want to assign to the variable. There are several sources that the value assigned to a variable can come from. The three sources we are going to cover are literal value, variable, and user input. Literal value source is when the value is hard-coded, that is written in the software. Examples of variables with hard-coded values are total seats and total passengers. As you can see on line 13, the value assigned to total seats variable is written into the code, that is, it is hard-coded. The same applies to total passengers. On line 18, which is 17, is the value assigned to it. So this is known as literal value. Values can be assigned to a variable at creation time. So total seats variable is created on line 13, and on that same line, it is given a value. That is assignment at creation time. If value is not assigned at creation time, it can be assigned later on in the code. An example of a variable that got assigned a value later on is total passengers. As you can see, total passengers variable got created on line 14, but it was not assigned a value, that is, no value was stored in it at the time that it was created. However, later on in the code, on line 18, it is assigned a value 17. Now, variable assignment. Variable assignment is when the value that is stored in a variable comes from another variable. An example of a variable whose value comes from another variable is available seats. As you can see, available seats was created on line 15, was not given a value at the time, but later on in the code, on line 24, it is given the value of total seats variable. Remember, the equal sign will take the value on the right-hand side, in this case, the value stored in total seats, which presently is 20, and it will store that value in the variable on the left-hand side of the equal sign. Since that variable is available seats, the value 20, which is the value of total seats, will be stored in available seats. So that is variable to variable assignment. Remember, assignment means you are storing value in a variable. Let me mention in passing that instead of assigning the value of a variable to another variable, you can also do computation and then assign the result to a variable. And that is what is happening on line 26. You have calculation taking place before a value is assigned. Total seats minus total passengers. Total seats, by putting the mouse over it, we know is 20. Total passengers is 14 because that's what the user entered. And you know what the minus sign does. Total passengers will be deducted from total seats. You will now get a result. That result is what will be stored in available seats. When we complete execution of line 26, the value stored in available seats will be 6 because 20 minus 14 is 6. The third source from which the value that gets stored in a variable can come from is user input. That is, a user types in a value and then clicks a button or presses the enter key. And then the value moves through a chain of processes and ends up in a variable. An example of user input source is line 21 of the code on the screen. What this line does, that starts with integer.parseInt, what it does is it presents the user with a field and the request for the information the user is to enter. The user enters the value in the field, and then when the user clicks a button to say the value has been entered, the value is then automatically passed through the code and ends up in total passengers variable. I'm going to demonstrate this to give you a clearer picture. As you can see, this screen that has popped up says enter the total number of passengers. And if you go back to the code, you will see that that's exactly what line 21 also says. So line 21, and when we go to the statement, it says enter total number of passengers. So let's get back to the screen. So I'm going to enter 14. So click the OK button, and after clicking the button, the value 14 is going to end up getting stored in total passengers variable. So here we go. The value 14 has now been stored in total passengers variable. Just to recap, one of the sources that the value that ends up in a variable can come from is user input. And that is what has just been demonstrated here. We ran the code, a field was presented to the user entered 14, and that ended up in the variable total passengers. Feedback is the act of giving the user information about the actions you have taken in your code. It is technically known as reporting. There are a number of ways in which you can output information from your code. One of which is to send information to a conventional printer, or to send information to an email, or to send information to a screen. In our case, we are sending information to a screen. In Eclipse, that screen is technically known as console. So in order to send information to console, you need to use what is known as system.out.println. System is a class that is built into Java. And out is an output stream inside the system class. And inside the output stream, you have a method that is named println. We will cover methods later on in the course. For now, you just need to understand that you specify system.out.println, and then inside the brackets, you specify what you want to print out. So in this case, we have code that receives two numbers from the user and outputs the result of adding the two numbers together. As you can see, some of the values passed to the println method are enclosed in double quotes, e.g., plus and is. This is because the values are literal strings. Java requires literal strings to be enclosed in double quotes. A literal string is a sequence of characters that is written directly into the code, so that whenever you read the code, you will see the value. In addition, a literal string is a sequence of characters that is not made up of only digits. Again, examples of strings that are not made up of only digits are plus and is. I seize this opportunity to point out that a number that is written into the code is a literal number. However, unlike literal strings, literal numbers are not required to be enclosed in double quotes. In order to join values together, you need to use the plus operator. More technically speaking, joining values together is known as concatenating values. So in a nutshell, to print out meaningful reports, you can join strings and variables together. So let's run the code so that you can see the output of these two lines. So as you can see, the code is asking me to enter the first number. So I'm going to enter 8. Next, the code is asking me to enter the second number. I'm going to enter 17. Having run the code, everything from line 19 to line 26 has been carried out. And this is the printout of lines 25 and 26. On line 22, the first number is received from the user. On line 23, the second number is received from the user. The result of adding the two numbers together then gets stored in the variable named result. And then on lines 25 and 26, we give user feedback. So if you look at the first line in the printout, you'll see that it just says 25, which is consistent with the instruction on line 25. The only thing that was specified in the brackets is the variable named result. And as you are aware, the result of the sum of the two numbers was stored in the result variable. That happened on line 24. Now the next line, having \n, it's tantamount to pressing the enter key. This is why in the result you have a blank line. Then the next thing is the first value the user entered specified. That is why you have 8. Then you had space plus space. That's why you have space plus place next to the first value. Then you have the second value that the user entered, which is 17. And then you have space is colon space space, which is why you have this in the output. And then at the end, we specified result, which of course is the actual value of adding the two numbers together. And that explains why you have 25 as the last thing printed on that line. So anytime in your code you want to do a printout and you want the result to go to the console, which is this white screen, Yeah, just use system.out.println. That's it for outputting information. It is now time for you to do another exercise. Before proceeding, go to Eclipse, then open the class file you created earlier named calculator.java. To open the file, go to Project Explorer, then expand the coding project, then expand source, then expand coding package, and you will see calculator.java. Double click it. So after opening it, save the code you wrote for the last exercise to a file on your computer. Afterwards, open coding_variables.txt file, which you downloaded earlier. Then search for code template for exercises. Once you find it, copy the code template. The lines you want to copy start from package coding all the way to the closing curly bracket. Then go to Eclipse and delete everything in calculator.java. Then paste what you've just copied. The calculator.java file should now look like this. Remember, your code is to go between these two lines. Now do exercise 2 in the coding_variables.txt file. So the exercise requires you to create a variable named first name, assign a day to the variable, that is, store a day in the variable, determine whether the data type of first name variable should be int, float, or string. On the next line, print out the value you assigned to first name variable. When you run your code, your answer should look like this. The value stored in first name is Ade. So pause the video while you're doing the exercise. If you have completed the exercise, you can resume the video in order to see the answer. These two lines answer the question. Remember, the exercise requires you to create a variable named first name. It then goes on to ask you to assign a day to the variable, which is done here. A day comes after the equal sign, and remember, whatever is on the right-hand side of the equal sign will be assigned or stored in the variable on the left-hand side of the equal sign. The question asks you to also determine whether the data type of the first name variable should be int, float, or string. And the correct data type is string. That is because string data type is for storing character values. A day is made up of characters. So therefore, the storage that you want to put a day in this case first name, should have a data type of string. So that completes that part of the question. The exercise further requires you that on the next line, which is line 13, print out the value that you assigned to first name variable. And remember, to print out any information, you use system.out.println. And then inside the open and close brackets, you specify what you want to print out. Remember, anytime the name of a variable is mentioned, it is the value that will be returned. When you run your program, what you should see is the same statement that you have up here, which is why we have this as the result. of running the program. The value stored in first name is Ade. So for exercise 3, you need to go to line 14 and change the value stored in first name variable to Buhari. This is the value that you need to change it to. And then on line 15, print out the new value stored in first name variable. Please note, you do not need to specify data type for first name when you give it the value Buhari, because you only need to specify the data type of a variable once. When you finish the exercise, your output should be like this. You now have a new line, which is the value stored in the first name is Buhari. So pause the video while doing the exercise. If you have completed the exercise, resume the video. So remember, the exercise requires you to change the value stored in first name to Buhari. So in order to do that, you just need to change the value that is on the right hand side of the equal sign. Because remember, in order to store a value in a variable, it needs to be on the right hand side of the equal sign. The question then proceeds to ask you to print out the value that you've just stored in first name. And again, to print it out, you just do exactly what was done on line 13. So nothing changes. And because the value of first name is the only thing that has changed, it will merely print out the new value, which of course is why you have this printout. Please note, if you get error, duplicate local variable first name, it means you have specified data type for first name variable on line 15. And this is against the rule. In the case of first variable, it got created on line 12. And you specified the data type there. So it is not right to specify it again. So remove it and the error will disappear. That ends exercise 3. It is now time to proceed to exercise 4. In order to do exercise 4, search coding_variables.txt for code template for swap exercise. Next, copy the template to calculator.java file in Eclipse. Copy everything from the Word package all the way to the closing curly bracket. Delete all the code in calculator.java. Then paste the template. Having copied the code template for exercise 4 into calculator.java file in Eclipse, proceed to the exercise. The exercise requires you to do the following. Using variable to variable assignment, in the code template for swap exercise, swap the values of first name and last name. so that the value of first name gets stored in last name variable, while the value of last name gets stored in first name variable. Use as many variables as you need for the swap exercise. This exercise is broadly similar to swapping the content of two cups. One cup, known as cup A, has red wine in it, and the other cup, known as cup B, has palm wine in it. The content of cup A must end up in cup B, while the content of cup B must end up in cup A. Please note, any code you write for the swap, it is to be on line 21 onwards. So if you need several lines, then you can create them. But don't write anywhere else in the code. When you run your code, the output must look like this. As you can see, in the first two lines, first name had the value of Ola and last name had the value okay. After the swap, first name's value changed from Ola to okay, and the last name's value changed from okay to Ola. Pause the video while you do the exercise. If you have completed the exercise, resume the video in order to see the solution. So this is the solution to the exercise. So remember, you are supposed to swap the values. So that means whatever was in first name needs to end up in last name, and whatever is in last name needs to end up in first name. So the first thing you do is you store what is in last name into a temporary variable or a temporary storage. In this case, we have named the temporary storage temp. Store the value of last name in there. Now you can put the value of first name in last name. Remember, whatever is on the right hand side of the equal sign will be stored in the variable on the left hand side of the equal sign. So first name on line 23 gets stored in last name, and then on line 24, the value that used to be in last name, which was temporarily stored in temp, that value is now stored in first name. This brings the tutorial to an end. The next topic will be condition statements. However, if you are interested in seeing what the swap app looks like on Android phone, then stay on for a demo. But please remember, the focus of this tutorial is on coding. Therefore, although I'm giving you a demo in Android, the objective is not to teach how to develop Android apps. Okay, the tool that I am presently in is known as Android Studio. Remember, you did your exercises in Eclipse. So Eclipse and Android Studio are both IDEs, that is, integrated development environments. They are for writing software. But with Eclipse, you can write software in various languages, whereas with Android Studio, it's only software for developing Android phone applications that you can write. To get the tool, just search for Android Studio in Google and you will see the link for downloading it. What you have on the screen is the file in which the code that does the swap resides. The only part that you really need to worry about is where you write the code that does what you want the app to do. In this case, the code that is going to do the swap. As is the case with Eclipse, you can either run your application in normal mode or in debug mode. In this case, we'll run it in normal mode. So the application is getting created. So the application has now been created on this device on the screen. Whenever you want to run an Android application, you can choose to install the application on either an Android virtual device, such as the one that is on the screen, or on a physical Android phone, like the one that you carry around. In this case, we've chosen to install it on the Android virtual device, which is a phone built into the Android Studio tool. So there are many phones that you can choose from. So I'm going to enter Aula in the first field and OK in the second field. So remember, when I click this run button, it's going to run through all this code. After the user clicks the run button, these lines of code will be executed in the order in which they are written. So the first thing that will happen is the first name variable gets created, then the last name variable gets created, and then on line 42, the first name the user entered in the first box will be brought in and saved in first name variable. The second name that the user wrote into the second box will be brought into the code and saved in the last name variable. And then the user will get a report. So what is happening here is a report is being built. So the user will get this report that tells it the value that it entered for the first name and the value entered for the last name. So after the report, the swap gets done. So just as you saw in Eclipse earlier, the value in last name gets stored in the temp variable as a backup. Now that we've backed up the value in last name, the value in first name can now be stored in last name. And then next, we can store the value of last name, which was stored in temp. We can now store that value in the first name variable. The value that was in last name has now gone into first name, and the value that was in first name has now gone into last name, which is the swap. And now the next line, we are reporting back to the user on the outcome of that swap. That's it. Let's run the application. So here we go. So very fast. Let's run through the entire lines of code, lines 40 to 54, and this is the result. So as you can see, the first name started off having the value of Ola, and the last name started off having the value of Okay. But after the swap, the first name had now changed to Okay, whilst the last name's value had now changed to Ola. So that's it, which meets the requirement of the swap. So this is the app on the phone. And anytime you want to run it, just double click it like any other app on your phone. This brings the Android swap demo to an end. So the next topic, as I mentioned earlier, is going to be condition statements.